Hello, good afternoon. We will wait just a few more seconds for the rest of the participants to join. So please be patient. We are shortly starting our webinar. Okay, so I think we may start our webinar today. I would like to warmly welcome all of the participants on our webinar, Digital Twin as a Crucial Step on the Road to Smart Factory. We are very glad and happy that our webinar has met with such a big interest of people from different areas and industries. And not to keep you long waiting, as we only have 1 hour today, let's get down to business. Let me present the agenda of today. Okay, so first of all, we will explain what is digital twin exactly and what are the benefits of it. Later on, we are going to provide you 2 real-life case examples providing the objective, so why it was implemented, the outcome of the simulation, and of course, we are going to provide as well some alternative scenarios for the future implementations. At the end, we also predict a few minutes for a Q&A session. So if there are any questions on your side, please feel free to use the questions and answer window where the questions might be asked. So after all, we will, of course, have a chance to answer them. Let me now present today's prelegents. My name is Paulina Bielec-Dubko, and I'm responsible for business development in Engineering Competency Center. My main role is sales and business development on international markets. Przemek Grzanka, Engineering Competency Center Director. Przemek has managed to establish cooperation with more than 30 international customers, and right now is leading Engineering Competency Center with more than 150 engineers on board. And Przemek is a huge enthusiast of Industry 4.0 and smart factory solutions. Damian.dudlo, our consultant and expert. Damian is an expert in digital manufacturing, material flow, and of course, digital twin solutions with more than 10 years of experience. And before we get into the main topic, just a few words about SIA in general. SIA is currently a top engineering and IT services provider from Poland, being present on the Polish market for more than 15 years right now. We are a part of a group, SIA Front, but together with our CEO, Grzegorz Mito, we operate quite independently on the Polish market. As you can see, we are present in 14 delivery centers in the biggest cities in Poland, and we are proud to have more than 5,000 workers on board, supporting more than 250 customers internationally. And let me right now give the floor to Przemek Grzanka, who will elaborate a bit more on our capabilities in regards to industrial software and digital twin solutions.
Good afternoon. It's a pleasure for me to meet you as well. So SIA Engineering Department and Competency Center was created and is focused to deliver top-class services for industrial manufacturing, production, automation. We aim to support companies vertically and horizontally, as you can see on the slide, throughout all areas of industrial engineering. As the only company in Poland, we are able to provide individual services separately on each layer of your company operations, but also a solution that combines vertical integration of all systems mentioned here. And then SII has also developed a benefit-oriented methodology for implementation of this offering, so-called Road to Smart. And so now our offering can be summarized in three main areas of activities. The first one, engineering services, is for all those clients who look for support with selected and defined competencies. We have extensive hands-on experience in building and providing teams in areas mentioned on the slide, starting from control engineers to all design works, both electrical and mechanical, up to assembly services, commissioning, and industrial software development. Second area is much more solution-oriented and evolved from our competencies throughout time. And we want to support our clients with knowledge and experience in providing turnkey machines and lines for selected production processes. Just to mention assembly, solutions testing, logistic material handling, as well as all kinds of robotic applications. We also provide electrical cabinets manufacturing and modification of systems already existing and plants. Eventually, the last but not the least area is industrial software. We support our clients in the road to smart factory through integration and development of all kinds of industrial software, starting with the top layer, so the production management systems, MOMs, through production execution and planning systems, MES and APS, up to all kinds of process control systems and visualization applications, so SCADA and HMI. Of course, one of the most important areas within industrial software offering is, of course, digital twin, which, as you will learn today, is a crucial step towards smart factory and production optimization. And now I will give the floor to Damian. So.
Good afternoon for everyone. Thank you, Przemek and Paulina, for great introduction. I will go directly to the topic of today's presentation. What is digital twin? Well, digital twin is a computer's model which give us many possibilities and opportunities. Digital twin represent existing factory or plant, include production processes and logistics, or planned production system in greenfield stage or brownfield stage. Well, what kind of new possibilities give us digital twin? Basically, digital twin allow us for simulation, and we can make many different scenarios thanks to this. Analysis, we can make many analyses, check the throughput, check the machine's efficiency, and so on. We are able to do optimization with genetic algorithms, for example, or optimization of the buffers. We are also able to make nice visualization in 3D dimension environment or in 2D environment. And this is everything in the area of the production, logistic, and warehousing. Przemek, say more a little bit about the highlights of the digital twin.
Yes, of course, there are lots of different benefits and highlights of digital twin. We've just listed some of them in here. Of course, this is not the complete list. However, we will make some summary of what we believe is the biggest benefit of digital twin, is that we are able to make all kinds of analysis based on different kind of input data. So starting, of course, the most obvious financial feasibility and profitability of plant investment, all kind of what-if scenarios, different kind of comparisons of different solutions, of different products, control, logics, and so on. We can use digital twin as a great tool for minimizing the margin of unexpected situations, as well as mitigating the risk of such situations. And of course, we can make effective return on investment calculation. However, what is the most important thing is that we can do it before we really put the real money on the table and we invest a lot into the hardware and all equipment. And as you will see later on in the cases, we can do really great analysis of future investments. So Damian, I give back voice to you.
Thank you, Przemek. So how we build the model? In the beginning, we need input data. We can collect them for you, or probably you get those data and you can share with us with this data. If we got input data, then we are ready to build the model, and model should give us the output data, the most interested KPI, for example, level of utilization, throughput, or show us where are risky places and bottlenecks. And there is much more different benefits, and everything depends from the project and from the project goals. Digital twin have structure. You see the top layer, which is 3D or 2D visualization, but under the visualization there is the data in tables which you give us to create a simulation model, and behind this everything stands control logic, which is control all the movements and all the processes behind the visualization. We can make simulation in point cloud if you don't have, for example, a layout, or you don't have some 3D models. Then we are able to make 3D dimension point cloud, and in this 3D dimension point cloud make the simulation. We are also able to create digital twin for you, which will exchange data. It will be possible to import data from databases and send them to some system which may use data from the digital twin. So this exchange data is in two sides. Mostly in our projects, we are using input data as you see on the screen. Those information are helpful for us in the first stage to make the offer, and after to make the digital twin for you. And you will see some of this data in the next two cases, which I will present for you. So how look the project implementation? In the beginning, we need to check your data and make the familiarization with your data, learn your processes, check how the process look. After that, we are ready to prepare offer for you and make some estimation, and later on prepare the project. In the end of our project, we will give you the answer for the questions, and we will achieve the goals, and you will be ready to implement those recommendations with the low margin of error. Case one, the introduction give you Przemek.
Okay, yeah. So now we can go to the business case. So the first one that you would like to know is the real life case. It was developed for Claire, one of the biggest furniture manufacturer in Poland. So what was the task? The task was that there is this factory already operating, and they were planning to change the logistics system in the sewing department. There were several goals defined, and the main was to compare logistics systems, which I will tell a little bit more in a second. There were some production planning aspects that the customer wanted to analyze. Of course, they want to verify different kind of scenarios, maybe make some experiments according to already simulated data, and find the optimal parameters and recommend the optimal number of devices. And the process that was being analyzed in here is that the product boxes travel between a station where worker have different kind of skills. This is an important factor because, as you will see during the simulation, the competency matrix was also required to be implemented into the simulation, that we will have the real simulation of how the worker works. Also, another thing, there was a requirement to implement or to integrate technology data. So all the production technology that is necessary to deliver the products should be an input data for the simulation, as well as some time scheduling, shift works, and things like that. So the process and the layout, if we can go to the next slide here, is that there are material cutting and initial sewing departments where the real process starts here, and now the material is being transferred to the assembly sewing department and the corrective sewing department. As I mentioned, and if we can go to the next slide again, then the main goal was to compare 3 logistics. One was made and one was based on the mobile robots, AGVs, and 2 other were based on conveyor systems in 2 different topologies. They were called Concept 1 and Concept 2. Yeah, so now, Damian, I give you the floor back again, if you can present the simulation, of course. So.
Thank you, Przemek. So now you see the simulation model. In the bottom of the screen, you see the control part. On the left side, there is a possibility by clicking the button to choose input data, which is stored in the Excel sheets, but we can also change it, and we can take this data from databases from your systems. In this example, we are based on Excel sheets. After that, we are able to load production plan, technology file, competency matrix, shift calendar, and those data are stored to the data tables. And for example, this is the production plan. 1 month production plan includes around more than 2,000 orders. There is technology with the routing of the product and with the cycle time for the product. There is also matrix competency, which telling us which worker have competency. When is 1, it means if worker have competency to work with some kind of product. So in this case, if worker 2 don't have in the cell number 1, it means that it cannot handle this product, it cannot manage this product because don't have skills to work with this product. In the top, we got the workers with the lower skills. In the bottom, we got the workers with which are the most qualified, and they are very flexible. So we are starting to giving the task to the workers with the lower skill, and after that we are going to the bottom of this table. We got some information about shift calendar, so we can run the simulation in different shifts. It's up to person who would like to make the simulation and make the experiment, what will choose, which calendar will run. Beside that, we got additional options that we can send 2 orders, for example, to 1 worker. Of course, this is drop-down list, so it is possible to change it. We can stop simulation after a few hundreds orders. We are also able to deactivate some station. Now we got 38 of them, but we can choose less than 38. We are checking the orders from the production plan, and we can also change the figure over there. And in this version, we also got the control panel for AGV, where we can choose the number of AGVs, which is very important for us, the speed of the AGV, average speed, and battery consumption and battery parameters, which we can also change. It depends from the producer and from our assumption in this area. The last part of the control panel is results, and the most important for us is throughput and simulation time. The throughput show us how many we produce, and simulation time show us how long it takes to produce the throughput over there. We got three different versions, but we got the same input data. We are using exactly the same input data. We can set the same parameters, and we are able to run this three separate models and compare them. So I will start the simulation. In the beginning, a little bit faster to warm up, and now I will slow down. And we see now, we see the HVs are travel between the stations, and they are moving the material according to data in the technology, with the technology ruling. What is the most interested for us? How long it takes to produce, for example, 500 pieces. So I can start the simulation with the full speed. And after a few seconds, I got the result that the throughput, 500 pieces, I'm able to do it in 2 days, 8 hours. I will save it to Excel sheet to compare this data with other versions of this model. So now I will run second version where we got conveyors. I will run it with the full speed. And after a while, I have the time and the throughput. So I will store it in Excel sheet. And of course, I will check the third version. I will run it with the full speed. And now I got the result. So I checked the version 1, version 2, and version 3, and here are the results. They are almost the same, but they are the same because I'm using almost the same input data. I put almost the same parameters. So now I'm interested what will happen if, for example, I will change number of AGVs from 2, for example, to 4. Do I'm able to produce more thanks to this? So now I'm again turning on the simulation. I lost the clock in my simulation, but it is not a problem at all. I will play the simulation with the full speed, and we will see the result. Now you see, this is my new result with the 4 HVs. And as you see, I saved 2 hours thanks to 2 additional HVs. There is many different parameters which I'm able to change and check the final results, compare them with the other version, and choose the best solution in my case. I'm also able to load different data and again run the simulation. There is many possibilities and different possible results. I will show you also the chart. This is the basic chart which is showing us the level of utilization for the workers. So now we see that only the one shift is open, shift number 2 and shift number 3 is closed, so it's the time unplanned. But I see the first worker from the competency matrix. They got the lowest skill, so they get the less work. It means I should increase the skills for these workers to send them more products. More or less the same information I got from the utilization chart from the stations. And here also I see that the utilization is the lowest for the workers who got the lowest skills. I can also check the chart for the AGVs. Now I see I got 4 AGVs, so it's don't make sense to add additional AGVs because they are waiting for orders. They are waiting for the tasks. So they are not very high utilized. In this case, I think this is everything which I would like to present you. I will back to the presentation and Przemek tell you a little bit more about the future steps or future possible development in this area.
Thank you, Damian. Yes, as you see, there were different kind of requirements on input data, different output data, different kind of analysis and recommendations, but that's not all. There are some other possible future development based on this model. One of it is to extend the simulation to the furniture frame area, where we can make similar analysis, and this is so-called step 1, and this is step 2 could be to integrate those 2 simulations into one workflow and then make analysis from the big picture of the whole logistics within this factory. So of course, the sky's the limit. The possible future development is only up to what we want to achieve, what is our objective, and what process we would like to analyze. So now we can go to the second case that we prepared for you today. This is more from FMCG industry. This is the brownfield, the factory. And the case is that there are some new production lines ordered to the factory. And the question the management has now is, can current logistics system manage this new production? The process that we are analyzing in here is that there are some AGVs, and they are transporting pallets with the ready product from the end of production lines. And there are 2 destinations where the product is taken. One is the warehouse, and the second one is the shipping area where the shipment is made. So the question that we have is to find optimal number of AGVs for the factory and do all experiments that are possible within this model. So again, Damian, please feel free to show the simulation.
Yes, now you see the simulation model. This is a 3D simulation model. I would like to say that each of model can have a 3D visualization layer. It's up to customer what expect from us. Then we can prepare 2 or 3D simulation. As before, I got some control panel which allow me to change some factor, make some adjustment, and set some settings. Now I will play the simulation and I will tell a little bit more about how it's working. Now it's running very fast with the visualization. I will slow down a little bit. Here are AGVs, the small ones. They are taking the pallets from after the stretching and after the labeling process. They are going with those pallets to the warehouse, or they are going with the pallets with the ready product to the shipping area to load them on the trucks and deliver them to the customer. The small HV to also deliver empty pallets to the lines, and they are making also those movements from this area to all of the lines. In this line, we got the mobile platform, which are taking care about the logistic processes from the end of the line and to the place where we are making the stretching for the pallets and labeling for the pallets. And now is the questions. If we add some additional lines, or if we increase the throughput, we increase the throughput for the production line, that we can manage these changes with the current production, with the current logistic system, or we have to make some kind of investments. And how much do we have to invest? So it means how many additional HVs do we need, or how many additional mobile platforms do we need to do logistic processes in this area. I will back to the presentation for a second. I will show just some charts like this one. We see that we just start the simulation and it should little bit moving. So it means we just start and the process is stabilized at the moment. We can also check different data in tables. We made already some kind of analysis because it takes some time to do it. So I will back to the presentation and show you in the presentation what do we check. So according this data which you see on the left side of this presentation page, we made the simulation and we check the small HV number, how much we are using, and what is the throughput. We see in the middle of this table that it don't make sense to increase the number of the HVs because we will not reach any more throughput. It will just stop somewhere in experiment 7 where we got 16 or 17 HVs. It will not rise anymore, even if it can the throughput can be lower. We do additional investigation. We check the utilization chart for simulation with the line efficiency 100%, and now you see this chart. So when is the color yellow, it means that line is blocked, and that means that this line is not very well operating by the logistic. So logistic is not coming on time to take the ready pallet and deliver it to the storage area or to the shipping. The line is blocked. If we increase the throughput for the line for 20% to 120%, then we see that this effect is even bigger. So it means that we have to more focus on those lines to make the optimization. We made additional calculation, and here you see the line number. Here you see the information, how many pallets per hour the line is producing. On this column, you see maximal possible throughput. Maximal possible throughput means that if we turn off the logistic processes and we just move the pallets from the end of the production line to the warehouse or to the shipping without any losses because of the logistic, then it is maximal possible throughput. Here you see the simulation throughput with the logistic, with the number of the pallets. And here you see how many percent we are losing because of the logistic processes. So the average loss is about 8%. and we made some additional analysis. So we increased the throughput for the line. So it means the line is working, is producing more pallets per hour now. The maximal possible throughput is, of course, bigger. Simulation throughput you see over there. And here we got the losses, and we see that we increase the losses. We increase the production line efficiency for 20%, but we double the losses because of the logistic processes. In next step, we change the number of the AGVs, the small ones, and we see that the impact for after this change is minimal. So this don't take any effect, positive effect. We start the investigation and we discover that it don't make sense to change AGVs in this part of the layout because they are not the bottleneck. The bottleneck is over there where you got the gray platform which is deliver pallets from the end of the production line to the stretchers machine. We made some tests and we discover that we need to add some additional platform over there to reach higher throughput. So besides 20 small AGVs, we got one big platform, and we see that give us the positive effect. Of course, we continue this analysis, and we finally found the correct number of the AGVs, and the numbers depends from the expect level of the efficiency for the production line, but it takes some time.
Okay, as you see in this case too, the first and the basic question was the number of AGVs, and during, as Damian already described you, it showed that not only this was a problem, the problem was also that we found a bottleneck in completely different area that we previously thought the problem is. So you see that there are many different opportunities that we can do it. However, there are of course a lot of possible future development because we can add to existing simulation also the warehouse simulation and search the optimal capacity there. And of course, we can try to switch from AGV system into the conveyor systems and so on. So I hope those two cases are the cases we prepared for you today. And just to summarize, what is important when you start your journey with digital twin into the smart factory is that you have to always think about your objective. You have to well define it, and you have to define it very precisely what you want to achieve. And you have to select and find the right process for analysis that is related to the objective. If you will keep this structure, then not only you will achieve one of your objectives, but then you can in parallel make some additional analysis and experiments that can, and you can all the time develop everything. And please remember, you can do all of it before you really invest the big money into the buying some equipment, hardware, and so on. So, to summary, also why we think the digital twin is a crucial step on the road to smart factory is that currently on the market there's a huge number of different kind of solutions, concepts, ideas, and checking all of them. Whether to invest in this solution or not, because we want to make our factory smart and we want to make our factory more efficient and working better. You can use a digital twin to check all of your scenarios. Or what if this is what I said at the very beginning of the presentation. So yeah, this is all. I will give the floor now back to Paulina.
Okay, so now's the time for Q&A session. We've noticed that we have some questions. Of course, if any question comes to your mind just now, please feel free also to ask. Let me see what we have here. So the first question we have, what do you use to perform the simulation?
Well, to perform the simulation, we are using the best simulation tools on the market. It depends what we would like to achieve. Do we would like to have a nice visualization, or we expect that the model will run very fast? Then we are trying to choose the proper tool to make the good simulation model and reach the goal in the end.
And maybe Damian, you can just tell what software did we use for those simulation we presented?
For those two, we use plant simulation because the plant simulation is quite fast. We are able to do 2D models, which you can use on the different computers without very efficient 3D card. But we are also able to do it with the nice 3D visualization. So in most cases, we are using Siemens plant simulation, but there are also different good tools. But this is the first choose, our first choose in the simulation and in the making digital twin.
Okay. Many thanks, Damian. I hope it addressed the question well. The next I see here on the list is, how long does it take to prepare a model?
So it's depend from the goals. It depends from the number of data, number of things which we have to taking care to make the simulation model. It's take around 1 month up to 2 months, but it really depends from the project and the expectation of the project and many different factors.
Okay, then I think we can move to the next one. Right now, a question more about costs, like how much approximately does it cost to prepare such model?
Okay, so maybe I will address this question. So basically, the answer is quite similar as to the previous one. It all depends on the complexity of the project, of the process, of the goals, of number of input data, and so on. And what I can say is that I encourage you to contact us directly. And we can case by case give you the estimation very fast. So because there's no right answer for this question, and there's no like a price list for that. I will come back to the how long does it take to prepare a model. One thing is preparing a model, and one thing is to collecting all the data for a model. And also this is quite a significant factor in terms of schedule for such project, because it always has to be good analysis of the process, that we collect all data that are really necessary and important to make the good simulation later on and to have the robust results at the end.
Thank you, Przemek, for that. The last question concerns the recording of the session. So if it's possible to share the recording after the call, and if it's recorded, so I can address that question. Of course, we are recording the session, and if anybody is interested or might think that somebody is interested in that topic, please feel free to distribute the recording and share the webinar that we had today. So yeah, that's all in regards to questions. I think we are a bit before 2 o'clock, so we were quite fast presenting all of the topics we had for today. I can say a big thank you to all of the participants that were with us today. I hope that somehow we managed to convince you that real data and good simulation might help you to avoid some unnecessary investment and actually go for and choose the right ones, and make actually the step towards smart factory, like factory of the future. And if it's the case, if it's so, then I highly encourage you to get in contact with me. It will be a pleasure for me to discuss any case that SII, Przemek, Damian, and all of us might be of some support to you. So I can only say thank you, goodbye, and hopefully we are in contact.
Thank you, bye.
Thank you, bye.